From drugs that clear damaged cells, to gene therapies that reset cellular age, and even nutrients that boost cell energy. Today, we're diving into the latest breakthroughs in anti-aging medicine. Stick around because I'll explain what works, what's promising, and what you should absolutely not do yet. Later, I'll describe a therapy that doesn't try to stop aging. It reverts key aspects of it. You won't want to miss the moral and safety questions it raises. What is anti-aging medicine? First, define terms. Anti-aging medicine doesn't mean making someone immortal. It means targeting the biological changes that make tissues fail, cellular damage, inflammation, mitochondrial decline, telomere shortening, and cellular senescence. Researchers target those processes to extend health span, years lived free of chronic disease, not just lifespan. Scientists track progress using biomarkers, epigenetic clocks, DNA methylation patterns, inflammation markers, organ function tests, and clinical outcomes like reduced disease incidence. So when I say breakthrough, I mean interventions that move those biomarkers, or show real functional improvements in humans, or strong, reproducible animal results. In a moment, I'll show you which drugs have already changed human biomarkers, and which ones only worked in mice. Senolytics, removing the zombie cells. One of the most tangible advances is senolytics, drugs that selectively kill senescent cells, the so-called zombie cells that keep secreting inflammatory signals. Removing them in animals rejuvenates tissues, improves mobility, and reduces pathology. In humans, combinations like dasatinib plus quercetin have shown reduction in senescence markers and functional benefits in early trials. Small clinical studies in people with chronic diseases, for example diabetic kidney disease, reported improvements in molecular markers and some functional tests. Researchers now aim to refine dosing, safety, and which patient groups benefit most. Why this matters. Senescent cells accumulate with age and drive chronic inflammation. If you can safely clear enough of them, even intermittently, you may blunt multiple age-related diseases at once. But remember, early human trials are small. We still need larger, longer studies to know long-term benefits and risks. Later, I'll compare senolytics to another strategy that resets cells rather than killing them. And the differences are fascinating. NAD plus boosters, NMN/NR, fuel for the cell. Cells need NAD+, a molecule central to metabolism and DNA repair. With age, NAD+ declines. Supplements like NMN, nicotinamide mononucleotide, or NR, nicotinamide riboside, boost NAD+ and have been marketed heavily. Clinical trials show NMN increases blood and NAD+ levels and is generally well tolerated. Small randomized trials report modest improvements in physical performance or metabolic markers, but effects are not dramatic or universal. The field is moving toward optimizing dose, delivery, and combining NAD+ boosters with other therapies to amplify effects. Important caveat: supplement market quality varies. Clinical trials use pharmaceutical-grade compounds under strict protocols. Over-the-counter products may differ. So, if you consider NAD+ boosters, prioritize evidence-backed formulations and consult a physician. I'll later explain why NAD+ alone may not be enough, and which combo approach is catching researchers' attention: rapamycin and mTOR modulation. Rapamycin and related compounds target mTOR, a central nutrient-sensing pathway. In animals, inhibiting mTOR reliably extends lifespan and improves multiple age-related functions. In humans, recent low-dose intermittent rapamycin trials showed tolerability and modest changes in aging biomarkers. Pilot studies exploring effects on fertility and cognitive markers have produced intriguing early signals. But rapamycin is an immunosuppressant at high doses, so dosing, timing, and careful monitoring are essential. Several clinical efforts, including small trials, are underway to nail down whether the animal promise translates to meaningful human health span gains. Why cautious? Long-term safety in otherwise healthy people remains an open question. Scientists are exploring rapalogs, intermittent schedules, and lower doses that aim to keep benefits while minimizing immune suppression. Later, I'll summarize who might benefit most and the red flags doctors watch for. Partial cellular reprogramming, rewinding the epigenetic clock. Now the most headline-grabbing science, partial cellular reprogramming. Instead of killing cells or giving them more fuel, scientists temporarily turn on a set of factors that originally used to make stem cells, to revert cells to a younger epigenetic state without erasing identity. In animals, short pulses of these factors improve tissue regeneration, reduce epigenetic age, and restore function in aged organs. Preclinical work shows substantial rejuvenation across tissues, and some groups have developed targeted versions, e.g., tissue-specific delivery, transient expression to reduce cancer risks. While human trials are still at an early stage, research teams have reported successful rejuvenation markers in cells and promising results in animal wound healing and nervous system models. This approach is revolutionary because it resets aging programs instead of just treating downstream effects. But it also carries serious safety questions. Turning on reprogramming factors improperly can induce loss of cellular identity or tumors. That's why the move to humans is cautious and closely regulated. At the end, I'll return to this idea and weigh it against other strategies. Should we aim to erase age marks or manage them? Other advances and combination therapies. Beyond single therapies, the trend is combination approaches. Senolytics plus NAD plus boosters, mTOR modulation with lifestyle changes, targeted gene therapies for telomerase in specific tissues, and precision medicine to match interventions to a person's biology. Some companies are testing gene therapy telomerase activation in disease contexts, and trials for targeted immune rejuvenation are beginning. Importantly, lifestyle remains foundational. Exercise, nutrition, sleep, and avoiding smoking still produce the largest, most certain effects on lifespan and health span. Almost every drug or therapy is more effective and safer and when paired with a healthy baseline. If you're wondering which of these could reach clinics first, my bet is on refined senolytic regimens and optimized NAD plus strategies combined with repurposed drugs like rapamycin in carefully selected groups. To recap, senolytics, NAD plus boosters, rapamycin/mTOR modulation, and partial cellular reprogramming represent four major avenues changing anti-aging research. Some, like senolytics and NAD plus boosters, already show early human signals. Others, like reprogramming, are spectacular in animals and cautiously moving toward human tests. But no silver bullet exists yet. Practical advice: don't chase unproven, expensive miracle clinics. Talk to a qualified clinician before experimenting with off-label drugs. Focus on evidence-backed lifestyle changes and follow the science. Larger, longer human trials in the next 5 to 10 years will clarify which interventions truly extend healthy years. Want a deep dive into how each therapy actually changes the epigenetic clock and an episode comparing top commercial NAD plus products? Comment below and I'll make it. Thanks for watching. If you found this useful, hit subscribe and turn on notifications. I post deep science breakdowns every week. Stay curious, stay skeptical, and take care of your body. It's the only one you've got.